let's continue our discussion of probability. We're going to look at random variables and probability distributions. So a random variable is not what we typically think of as a variable. So a better way to think of it is it's a rule. So it's some sort of rule that you've decided, and what you do is you assign a number to each outcome of an experiment. So this is a way for us to kind of organize data. So say that you were doing an experiment where you look at people's favorite soft drink. And so people might say, Pepsi, Coca-Cola, 7-Up, or they don't like soft drinks at all. And so you could assign a number to the outcome Pepsi. So if somebody says Pepsi, then you say, okay, I'm going to say Pepsi is a 1, Coca-Cola is a 2, 7-Up's a 3, and no favorite soft drink is a 4. And so that would be a random variable. You've defined a rule that assigns a single number to some sort of outcome. Now, if you're looking at an experiment where the outcome is already a number, then typically that's what you would use as your random variable. So for example, if you looked at the height of people in a classroom, their height in inches or feet in inches or whatever is already given to you as a number. And so that would be a really easy thing to say, okay, my random variable is going to be their actual height. That would be what we call a continuous random variable. So a continuous random variable is where you allow non-whole numbers. So if you were recording the height of people in feet, then if you have somebody who's 6.5 feet tall, then their random variable outcome would be 6.5. So you're allowing for non-whole numbers. When we don't allow for non-whole numbers, so if we require a whole number, that's what we call a discrete random variable. And that just means it's more like a staircase. You can have a random variable output of 1, 2, 3, 4, but you couldn't have something like 2.2. A probability distribution, so a random variable, we will usually call this x. And so when we say the probability distribution of x, this is talking about for a specific random variable x. It's just a table, and you just list if my outcome is 2, what's the probability of having that outcome? If the outcome was 3, what's the probability of having that outcome? It's just a way for you to organize the data for your probability for your random variable that you're looking at. So let's take a look at this first example here. A group has 6 men and 7 women. 2 are going to be selected for a committee. Let's let the random variable x represent the number of women selected. So if we have a committee of 2 people, on that committee we could have no women, we could have 1 woman, and we could have 2 women. So there's only 3 possible outcomes for this particular random variable. Also, they're all whole numbers, 0, 1, or 2, and so that would be a discrete random variable. So let's determine the probability distribution for x. So first, we're going to list, x, and then the probability of x. This is what we call our probability distribution. Okay, so it's just a table. Typically, it's like a T chart like this, but it could be horizontal as well. Our random variable could have, so we said there could be no women on the committee, there could be 1 woman on the committee, or there could be 2 women on the committee. Okay, so now we want to find out, okay, what's the probability that we had no women on the committee? What's the probability that we had 1 woman on the committee? And what's the probability that we have 2 women on the committee? So now this is back to just a simple probability question. Figure out how many ways could we make a committee, and then we want to figure out how many ways could we make a committee with no women, with 1 woman, and with 2 women. Alright, so let's see. How many ways total could we make a committee? So total ways to make our committee. Well, let's see. We're going to pick 2 people from a group of, let's see, this should be 13. Yeah, 6 plus 7 will be 13. So out of 13 people, we're picking 2 of them. Nothing in the problem says that there's like a title that people get, so there's no ordering on these people. So we want a combination then. From 13 people, we're going to choose 2 of them. So the combination of 13 into 2, that comes out to be 78. So the total number of ways that we could pick any 2 people, there are 78 ways we can do that. Now, let's see, how many ways can we pick a committee with no women on it? So if there are no women on that committee, then that means we only selected people from the 6 men, right? We completely ignored the women. So from the 6 men, we chose 2 of them. And again, there's no ordering, so this would be a combination of 6 into 2. And there are 15 possible ways that we could do that. So then we have then that the probability of making a committee with no women is going to be 15 out of 78. And you can leave your probability as a fraction, or you could rewrite it as a decimal, 0.1923. And so we want to do the same thing now, but how many ways could we make a committee with 1 woman? Exactly 1 woman. Not, so a committee with 2 women technically also has 1 woman on it, but we're saying a committee that has exactly 1 woman. Well, if that's the case, then that means that from the 6 men, we selected exactly 1, and from the 7 women, we selected exactly 1. And so we want to multiply these 2 together, and so we end up with 6 times 7, which is 42. So our second probability, there are 42 ways that we could choose our committee with 1 woman out of 78 total. And so you could leave it as a fraction or write it as a decimal, 0.5384. And so finally, we want to figure out, well, how many ways could we make a committee with 2 women? And that means that now we've ignored the men and we just select from the 7 women. So from the 7 women, we're going to select 2 of them to be on the committee, and this gives us 21 total. So let's see, 21 out of 78 should give us 0.2692. Couple things to notice here. If you add up the probabilities, so if you take the sum 15 plus 42 plus 21 all over 78, you should end up with 78 out of 78, which is 1. So if you've added up everything within the probability distribution, you should get 1 because you've represented the entire system here. Okay. Alright, so that is setting up a probability distribution for a random variable. Remember, a random variable is just a rule that assigns a number instead of words. So now, when we look at this probability distribution, which is this thing right here, the chart, if we see the number 1, we understand that that means that there is 1 woman on the committee. So instead of writing the probability of 1 woman on the committee, we can just say the probability of 1 instead, because the random variable has been well defined so that we know what that number represents.